All right. Hi. Good morning, everyone. I want to say thank you for joining today. It's absolutely fantastic here. I mean, so many great speakers. I was born and raised here. This is my home country, and it's really exciting for me to be here with you today. We're gonna talk about microservices today, and maybe we can start with a question. If you're doing microservices or getting into microservices, can you please raise your hand? Okay. A lot of relevant crowd. That's nice. All right, awesome. Well, we can start by maybe talking a bit about my story and how I got into microservices to begin with. If we go backwards a few years, I used to be a sort of full stack developer, heavily on the front end, React, all that good stuff. I saw myself as a full stack developer. I could download Express and set up an app, so I must be, right? And it was fine. And then I joined a company called DAZN. You might know it, you might not. And as soon as I joined that company, I suddenly got thrown into a very deep ocean of growth. The company was scaling super, super fast. And some of my immediate things that I noticed were that it was a very high performance environment. The focus was on shipping really fast and very often. The teams were set up to be autonomous, full ownership, design, testing, delivery, maintenance, really invested in a business domain. And there was a lot of scale, tens of millions of daily users watching live streams and processing payments and catalogs and landing pages. And these are things that were very stranger to me. And it turned out that the thing that at the core, that the heart of all this that enabled this scale and this performance was really microservices. Again, the growth was huge and microservices was the enabler for this thing. Now, fast forwarding to today, I can safely say that I've developed years of passion for microservices. I've transitioned to be a mostly backend. I mean, I can write some React code, but you really don't want me to. You really don't want me to. But yeah, I can safely say that my passion is in the backend and microservices and distributed systems. And I've learned some pretty interesting lessons that I want to share with you today. And let me introduce myself then. So hi, my name is Ariel Weinberger. As I said, I'm an Israeli at heart. I'm living in Amsterdam in the Netherlands these days for 5 years now. And again, super happy to be here. I'm currently a VP R&D at Application. Yeah, nice. We're doing some pretty awesome stuff. We're developing fully open source tools for the community, for backend developers that help developers ship really fast and focus on coding what matters so that they don't have to worry about boilerplates and any boring kind of infrastructure chores. So check us out. Super, super interesting. Previously, I was an engineering manager at Serverless. And I really love producing content and sharing my knowledge. And that's why I'm also very happy to be here today. So back to the microservices thing, I'm going to state something that's perhaps obvious. I mean, building microservices or any distributed systems is really challenging. I mean, you can do it. You can spawn something on some cloud provider and make it work. But if you want to make it scalable and you want to support your growth, it's challenging, right? And when I got thrown into that stage where I had to upskill very fast and turn into a proper backend developer at scale, I had a few things that I really had to learn and some high-level stuff, like why are microservices so challenging to build? There are a few things that we want to accomplish. Our challenges are also our goals, right? So the first one would be reliability and high availability. Basically, whenever we develop something, we want to make sure that our users are able to use it as we intend to all the time, wherever they are, right? That is a given. We need to scale. So maybe you work for a company that serves thousands of users today and tomorrow you want to serve 10,000 and next month you want to serve millions. So you need to have an architecture in mind that supports that growth. And obviously resiliency, right? We know that servers will fail, machines do fail. We want to set them up in a way that if they do and when they do, they're going to get back up, they're not going to affect our end users. Obviously there are some more important concepts, but I think the main ones that were immediately noticeable to me are these 3 or 4. And again, a front-end developer, getting into these foundations, I realized I really, installing Express and running an app is not enough. I need to have some solid foundations for solid backend foundations if I want to do it right at scale. And I want to quickly go through these foundations with you. So one of the obvious ones is statelessness, right? Basically, we tell our services, you don't know anything. If you need to store something, a user information, an order, you use an external database, right? We don't want our services to store state. We, most of the time, prefer horizontal scaling, right? So we prefer to tell our awesome services that they're too awesome to handle things on their own, so they should replicate. And this enables us to do load balancing. It's pretty much if you, I don't know how many internationals we have here, but if you went to a falafel stand and you stood in line, it wasn't really a line, it was more like a load balancer. You basically, it works like that, all right? But yeah, we need to balance our load. And this is how it works, right? All these three things together. We have a service, it gets replicated as the load comes in, and our load balancer distributes the loads, right? So all these three services combined enable us to get there and handle scale. The next one is redundancy. So basically, you buy yourself a new home, you're excited, you want to buy a sofa, you live with your partner or your wife or your husband. Are you going to buy a sofa for 20 people? No, that's a waste of space. But you also don't want to buy a small sofa so that when your friends come over for dinner, you can have them sit with you. So really, it's one of those things where we don't want to pay too much just because we have a peak at some point, but we do want to have some redundancy because things will fail, and when they do, we want to be able to continue operating and continue running. So this is what good redundancy looks like, right? We have two replicas, healthy performance, healthy load. One of them fails, and then since we configured it properly, the traffic goes to the remaining one and it handles it until it spawns again and we're back to normal load. So you want to have a healthy amount of redundancy for cases like this. Now, pretty obvious one, strong consistency. We tell the user, okay, you change your password, and we can guarantee that once they change their password, it happened, right? It's reflected everywhere. And the opposite of that is eventual consistency. We tell them okay, but we really cannot guarantee that that's going to happen, right? If they upload something somewhere and we need to generate subtitles or whatever, we tell them it's fine, but we have some stuff to do in the background. So these are some basic concepts that I had to upskill myself in, and you know, maybe they're obvious to some of you, but they weren't to me. But there is one thing that I noticed over the years of working at the Zone and at Serverless and other places, where when you design systems and you want them to be scalable and robust, it's communication that really matters. Not just between us, partners, friends, also in microservices. Because if you don't do communication right, that's like a very obvious point of failure for the services, right? And that's what I want to focus on today. Because I think if we get communication right, we solve a lot of problems. Database is another problem. Maybe next year I can talk about it. But communication is another important one. Now, I think we should zoom out for a moment and remember that we deliver features, not microservices. Whatever you do, you could be running an e-commerce website. Your users don't care about your microservices. All they care about is that they press a button and they order an iPhone or whatever. And it's important because features like this that the users use, they are our application. These are things that engineering teams sit down and spend time on. And stuff like changing your password and creating a thumbnail and sending a marketing email, these are features, right? And not all features are the same. And when you approach designing microservices, it's important to acknowledge that they're not the same. So that when your engineering teams or yourself are sitting down and working on a feature, you got to ask yourself a few questions. So first question we're going to ask is, can I afford for this to fail at all? What happens if it does? If the user changes their password and I tell them it's fine and then it's not. Their password manager already saved it, right? It's not great. What happens if we rely on multiple services to do something and one of them fails, right? How much latency can we accept for a specific operation? And there's more, right? But just to give an idea. And when we answer those questions, we should know how to choose the right tool for the job. That's going to tell us everything we need to know, for the most part, to choose the right tool. And when you approach designing features and you want to choose the right tool, you're faced with this, right? So like, oh my God, my company works with Kafka, so I should definitely use Kafka. Or I've heard of RabbitMQ, it's probably good. Or should I send a request and SNS and pubsub and Redis and Kinesis and SNS? And, there's a lot of stuff going on. And many times, we go for a solution just because we have it and it's available and whatever, let's use it. Or we might not know enough. So we go for something that we Google for it and it says it's good, so it must be good, right? And the focus for today, I want to zoom out a bit. And instead of talking about specific technologies like Kafka and RabbitMQ, I want to talk about techniques. Because if you think about communication between microservices, you can really categorize it at 4 things for the most part. HTTP requests, synchronous stuff, message queues, pubsub messaging, or event streaming. And these are the techniques that I want to talk about today. We're going to talk about each one of them. We're going to talk about use cases. We're going to talk about advantages, disadvantages, and I try to make it a bit playful with some animations to make the concepts clear. So let's start with synchronous HTTP requests. I mean, these are things that we're all pretty familiar with. You know how to make a request, I assume. And it's pretty basic. Client sends a request, server will do something and return a response. And again, this is synchronous request response. And it looks something like this. Client wants something, server processes it, and then returns a response. Advantages, right? If you do it right, REST, gRPC, whatever, GraphQL, then you're going to be stateless, and that's going to make everything very cacheable, so that's fantastic. It is synchronous, so if you need a strongly consistent operation, that's great. But that's about the only advantages, right? Some of the disadvantages, single receiver, right? You send a request to one service. You cannot send the same request to multiple. You have to send different requests. So if you have a case where different services rely on something, you have to make individual requests. Services may be unavailable. We're going to see an example of that. Latency may be high. We're going to see an example of that as well. And it tends to be expensive to scale. And I'll show you why. So some use cases where I think I would use that is if a user changes their password and I have to absolutely guarantee something on my backends, I would use HTTP calls because I know that if I got that 200, it's good. Changing payment details or any potentially critical destructive operation that we need to absolutely guarantee its strong consistency. And I want to show you an example. User wants to change their password, right? It goes to the auth service, communicating with the database. We know that if we got a successful response, their password has been changed. And that's important because if it's not, well, the outcome is very scary for the user. Now, I want to show you an example of where I wouldn't use HTTP requests. So in this example, we create an order in the backend, we generate an invoice, and then we send it to the user via an email. Now, you can see that the connection is hanging, right? The user is waiting, there is a loading spinner, they're submitting an order, and all these things happening in the background. And let's think about all the bad things that can happen here. What if the invoice generator is not available? What are you going to send in the email, right? There's no invoice. Look at how long our users are waiting. Now imagine if you have a barrage of thousands or unexpected spike of requests, your only way to scale these services is to create more replicas, and that's expensive, right? So that's not a great use case for HTTP calls. And the next methods I'm going to talk about are asynchronous methods that help us deal exactly with cases like that. And I'm going to start with the message queue that you might very well be familiar with. So basically the way it works is messages are put into a queue. Other services or workers actively read from that queue. And usually a single message will be handled by one consumer. Now, some of the advantages, if you have a first in, first out order of operations that you want to preserve, that's great. It's asynchronous, so things that need to happen at a later point in time. Stuff like rate limiting, throttling. If you have an operation that you need to slow down a bit so that you save some money because your servers are expensive, that's fantastic, and it's very, very resilient. If one of your services consuming a queue becomes unavailable, the moment it comes back up, it can continue reading. That's something we didn't have in the previous example, right? Some disadvantages is that it does add some complexity. You have to start handling failed messages suddenly, which with HTTP, they simply fail. And it's really not suitable for real-time operations. You usually use it to throttle things down. So just bear that in mind. Some use cases, marketing emails, generating subtitles for videos, generating thumbnails, and any post-processing operation or resource-intensive operation where you want to throttle or limit the rate. And I want to show you an example. In this example, you're going to see that the user uploads profile picture, and then we want to generate thumbnails for that picture. Our thumbnail service is expensive. It has some GPU or whatever. We don't want to create endless replicas of it. We want to control that. So we use a message queue to rate limit those messages, right? We upload the picture, it goes into the queue, and then our thumbnail generator at its own pace picks up messages, generates the thumbnails. That's a great use case for a message queue, right? I'm not going to dive too deep into technologies. All of these can do this in one way or another. RabbitMQ can do it pretty well. Kafka can do it very well, but it's very complex to operate. So if you're in Kafka already, that's fantastic. And obviously you have SQS for AWS or pubsub. They're both fantastic. Pubsub wasn't designed to do that, but over time, like you can do it. If you want to rate limit with pubsub, you can. It's not as straightforward as SQS, but if you're in the clouds, fantastic tools. If you got RabbitMQ, fantastic. If you got Kafka, then you're good. All these can achieve that. Pubsub, messaging, right? As the name suggests, you have services that subscribe, services that publish, and the delivery is facilitated by a message broker. And it looks something like this. So you have a publisher, publishes messages onto subscribers, and that's very simple, right? Some of the advantages, you have multiple subscribers. That's something we haven't had before. Like you want to publish something that multiple services are concerned with. That's great. You can use that. Typically, messages get delivered, quickly. There's no rate limiting or anything. And it's a pretty basic way to start doing event-driven development. If you publish somewhere and subscribe somewhere else, you're very much, starting to do event-driven here. Some of the disadvantages, in some implementations, unhandled messages tend to evaporate. If you think about SNS on AWS, services that don't handle the message is gone, right? So you have to think about that. And it has more operational overhead. Again, it's not a HTTP request. You don't just send it. I mean, you have to bear in mind what happens if my requests fail to deliver. Some great use cases for that: publishing metrics, real-time serious, fire and forget operations, or if you're in AWS, you probably know the famous fan-out pattern where you use messaging like SNS to fan out to other services. So this is a very, very common pattern. And I want to show you an example, right? We have a rental car. The rental car every minute will publish metrics to the metrics collector, and then the metrics collector will use pubsub to publish these messages to other services, right? We send this every minute, and we don't mind if one of those messages evaporate because it's going to come back in a minute. So this is a great use case for pubsub. It's relatively cheap. It's not real time, but it can get there very close. And we don't mind if things, don't get delivered. Again, some technologies that do that without getting too deep into that. RabbitMQ can do it. It's a message broker by definition, right? Redis can do it. It can do a lot of things. But I would say if you're doubting between the two, if you want something that is extremely fast and your messages are small, Redis can get you to like semi-real time. RabbitMQ is a bit slower, but will scale better and can handle larger messages better. If you're on SNS, it's fantastic on AWS, or pubsub for GCP. That's what it was meant to originally do. And the last one for today, and this is one that I'm very excited about, is event streaming. And as much as it is a technique, it's also a mindset, right? And I actually want to ask a question. Is anyone here in their company doing event-driven design? Can you raise your hand? Okay. All right, cool. Well, this is one that I'm very excited about, and I'm going to tell you why. Event streaming, in many ways, is very similar to pubsub. It shares a lot of characteristics with it. Events are published by publishers, and they are consumed by consumers. And in most implementations, they are persisted to disk. Now, if you consider SNS from pubsub, it's not persisted to disk, right? So this is an important point that we're going to talk about in a moment. Events have an offset, right, as they're stored on disk. So the first event has an offset, the one after, and they can be replayed. And that's very powerful. I'm going to show you an example. So you have a user. The user wants to pay $1,000 to his lucky friend. It goes through the payment API, and the payment API, using event streaming, wants to publish the fact that a payment has been successful. And what you're going to see is that the event is going to go into the stream and then published to the consumers. And each one of those consumers knows what is the last message they read. And as the message gets sent, it also gets persisted to disk and gets an offset. So this is what it looks like. The first request will come in, published, and then saved with offset 0. The next one, offset 1, 2, 3, and so on. And this is very, very powerful because at any given moment, we can replay messages. If one of those consumers fails at index 2, it will come back up and keep playing from index 2. Or it can replay if it needs to from index 0. Very, very powerful. First in, first out. So all implementations that I know of can let you handle things in the order they appeared in your system. It's very, very fault tolerant because if one of your services fails, again, it can replay. If your solution, like whatever you're using, Kafka or whatever, fails, it's persisted to disk, so it knows how to continue. And performance usually in these systems is extreme. You can get to millions of messages per second, and that's what they were designed to do. Some of the disadvantages, it has a higher operational overhead. Naturally, these systems tend to be a bit harder to operate. It's more expensive to scale usually, and it really does require a shift in mindset. You don't just introduce this, event streaming thing and like, yeah, all right, well, let's just publish messages and consume them. You need to get into the event-driven mindset. Otherwise, it's just you're not gonna get the best of it. Use cases, event-driven design, real-time applications and processing. If your users are browsing your website and you want to process what they're doing in real time to give them recommendations, like that's the kind of stuff you use event streaming for. Streaming of transactions, like in the bank example, and stuff like metrics, logs, BI, anything. Any event in your system can go into your stream. Some technologies that I know of, Kafka, designed to do this, does this extremely well, at scale especially. Amazon Kinesis, I'm not going to talk about because it does do that, but it's an animal of its own. If you've used it, you know. RabbitMQ, not here. It can do a bit of it. The main disadvantage and the reason it's not here is because it cannot replay messages. And that's blocking us from doing event sourcing, right? Now, a lot of tools and a lot of techniques. And I have perhaps a cliche to say, and that is, when I started designing systems and suddenly, well, you have to design a system for millions and tens of millions of users every day. I was like, okay, I know this, and I know message queues, and I know pubsub, and I know Kafka, and that's great. And every time I approach designing a system, and I come with my baggage of tools that I know, I realize I don't know. So, the cliche disclaimer here is, with all this being said, we continue learning, and the next time you're going to design a system, you're probably going to have to learn a few good things and hopefully share it with your colleagues as well. And really, my goal with today's talk was to talk about some of the fundamentals, some of the challenges in distributed systems, perhaps introduce you to some of the techniques and tools that you might or might not know already, so that next time, whether you're an engineer, you're a leader in tech, you're an architect, whatever, you're in a room and they're telling you, hey, we're switching to microservices, or we're breaking the monolith, and we're using Kafka, or we're using this and that. I want you to know and be an active participant in that discussion. Give your feedback, design the system, understand the reason you're using a queue and not a HTTP call, right? So hopefully we got that. And yeah, with that being said, I want to say thank you very much. Thank you.